Ready to find your flow? AFSA's got you covered.
That's right. The hands-on training lab in Richardson, Texas is where you trade PowerPoints for pipe wrenches. Real tools, real systems, and real experience you can actually use.
And if you're ready to test your skills, check out the hands-on NFPA 25 workshops, where you'll inspect, test, and maintain live sprinkler systems and fire pumps. No simulations, no fluff, just pressure, flow, and know-how.
It's the perfect way to get under pressure without cracking under it.
So get fired up and register today at firesprinkler.org. Spots fill faster than a charged branch line.
AFSA, where you don't just learn the code, you live it. Welcome to the K Factor podcast, where we turn up the heat on all things fire protection. Brought to you by the American Fire Sprinkler Association, this podcast sparks conversations about the latest technology, trends, and tools shaping the industry. Join the AFSA tech team as we fan the flames of innovation in fire safety.
Welcome to the show, the K Factor podcast. We're here, of course, with Eric and Nate, and we're here with Steven with Plumas Technology. Welcome. Just
Thank
Plumas.
You.
I'm sorry. Yeah. Thank you for coming out and speaking with us. Very interesting thing that we're doing right now is we're installing the auto mist in the lab so we can get people trained up on auto mist. New technology. How long has it been around?
So Plumas was founded back in 2008. So the very first version of AutoMist was developed then. Since then, we've had 5 versions of AutoMist to get us to where we are today. And the technology has changed in each of the systems that we've developed. And the current version of AutoMist that's being used in the UK has been there for 7 years now. And in the UK, we've got about 15,000 installations, home installations with the system installed. And it's only now we have a UL certified version of AutoMist that we're now bringing it to the United States.
So when did that happen?
So that's only just recently happened. We had our UL certification completed last month. So it's been a long process. We first brought the AutoMist system to the United States about 5 years ago through AIG Insurance, where they wanted to use the system in properties where there was problems with water supplies and there wasn't enough water supply to feed a traditional sprinkler system. So they were looking at a water mist option. So we did those pilot installations through AIG Insurance, and as a result of them, it was very clear that the product couldn't be launched en masse in the US without having a listed version of the product. So at that point, we spoke to UL, and we've been developing a relationship with UL over the last 5 years. And the issue we had with trying to get the AutoMist system certified in the UK is we couldn't find any certification bodies that were willing to certify a new technology because there was no existing standards that they could certify it against. So what UL were very open to was embracing the technology, and much of that time has been spent working with UL to develop a standard in order to certify the system against.
What's that process been like? I think a lot of people, I guess before we get into that, what is your role with Plumas?
So I am a technical sales manager. So my main role is I'm speaking to customers and stakeholders and fire marshals in the UK, because with this kind of system, it's not a standard sprinkler system. It's not a standard mist system. It's all new technology. So a lot of my role is explaining the technology to various stakeholders and also talking them through the evidence that we've built up over the years to prove that doing something a different way to the traditional way can still provide equivalent or better results than a standard water mist or sprinkler system.
So what was the process like obviously the standards are different in the UK versus the US. What did you've told me that you've had to almost kind of help with this standard, or with UL, of course, leading that direction. What's that process been like?
Yeah, I mean, it's been a very long process, a very slow process. But it's a process that we had to go through. Yeah. And it's taken a lot of time and a lot of money to achieve, to get to where we have today. And with the adoption of the electronically activated nozzle, which is the type of nozzle that the Automist system uses, that's been adopted into an FPA 750. So there is a definition now of that type of nozzle within the code of the NFPA 750 of an electrically operated nozzle.
So NFPA 750, for the listeners, is the standard on the water mist fire protection system. So it's not NFPA 13 that we're used to for a sprinkler system.
No. So the listing that we've achieved with UL is specifically for 1 and 2 family dwellings. So the NFPA 750 is a standard for water mist, but the 1 and 2 family dwelling is a part of NFPA 750 because it also covers other applications. So what we're really talking about with Automist here is the equivalent to an NFPA 13D standard system.
So I guess I'm still curious on how do you approach UL and say, hey, we've got this and we need to start this?
Well, we thought it would be a lot easier and smoother process than it was. It was a big, steep learning curve for us. So the co-founders of Plumis, William and Yusuf, they're still with the company now. They went over to UL and we started to have a discussion about the existing product we had at the time. And they looked at it and they said, this product is not going to be a product that we're going to be able to do. But they were very good at working with us in telling us what we needed to do to improve the product in order to go through this process. So it has been a very much of a two-way communication with UL. It's been good from their perspective because, like I say, for them to develop a new standard for this type of technology is a lot of work and quite an achievement for their point of view. And obviously, from our point of view, we've had to change so much of the product and improve the product along the way in order to get to the stage we are now, where it can be an internationally recognized listing that's associated with the product.
So what makes this product Automist?
Okay, so we have the biggest difference with this system is we interlink the system with a smoke detector. And we use a smoke detector to initiate the system to come out and look for the fire. So the other big difference with Automist compared to a traditional sprinkler system is we put our nozzle on the wall instead of on the ceiling. And the reason we do that is because the way water mist works compared to a sprinkler system, we want to try and get as much of the mist directed at the fire as we can, as opposed to wetting all the surfaces and using that to suppress the fire. The water mist, the particles evaporate, and as they evaporate, it takes the heat and the oxygen away from the fire, which causes the suppression. So what we don't want to do by putting the water mist nozzle on the ceiling is to have to cool that hot layer of smoke and gas that's building up on the ceiling, and we want to try and get as much of the water mist into the fire so that we're getting the most efficiency from the mist. So the nozzle's mounted on the wall, and it uses a thermal sensor. And when the smoke detector activates, the system will come out of the wall and it will scan the room, and it will build up a thermal image of the room looking for a fire. And if it identifies the fire, it will lock on at the angle where the fire is, and it will spray all the water through one nozzle. So one of the big advantages of this type of electronically controlled nozzle is that we can guarantee that only one nozzle will ever activate. So that's particularly useful when we look at the water supply that the system needs. So when we're doing calculations, we only have to calculate or allow for one nozzle to activate.
So one nozzle, so it oscillates, right? So
Correct,
self-oscillates. And what are some challenges that you run into when you're explaining this technology? Because it seems stateside, I'm sure there's some heels in the ground.
Oh, there is everywhere. Yeah. I mean, sprinklers have been around 150 years, yeah? And the technology hasn't changed a huge amount, mainly because it was such a good design in the first place that it came up with. And everybody knows sprinklers, right? Everybody knows what they do and they know how they operate. They've got proven reliability. I think when you're introducing technology as we are, but even just a different way of operating that nozzle, there's certainly a lot of skepticism around. And we've seen it in the UK, we've seen it from the contractors we spoke to here, and I think people really need to see the system and understand how it works. And then they say, oh, okay, get it. So we've spent a lot of time and effort. We've had to test our system in the UK probably more than any other system has been tested, because we've had to build up this library of evidence in order to prove to stakeholders that the system is a viable suppression system, and it's not some electronic gimmick that's trying to act as a sprinkler.
So you mentioned that the device comes out of the wall, makes a thermal image of the room. Can you talk a little bit, and I think this is something we kind of discussed, kind of in our meeting earlier. However, can you go into a little bit more detail on what that picture looks like and how it determines, kind of what's a fire and maybe what's another heat source in the room, prevent false activations, things like that?
Yeah, sure.
Especially that's trying to combat that newer technology.
Yeah. So one of the first questions that everybody asks about the ultimate system is, if I burn my toast and I set my smoke detector off in the kitchen, am I going to get sprayed? Okay, so
for me, it's definitely the candles, especially Christmas season.
Yeah, candles. Even you burn the turkey and you open the oven door, right? And we'll cool you down. So the way it works is, as the system scans the room, it's reading the temperature at different angles of the room. And what it looks for is it's looking for a very high temperature, which you just shouldn't see in a domestic environment. And if it sees that, it will spray straight away. And usually when we get that scenario, it's where we've had it where it's a cooking oil fire. And when the pan ignites, you get that big inrush of temperature, and it will see that and it will spray. It will also look for the spread of the heat signature. So what I mean by that is, if it's looking at an open fire or a log burner, it will look at that part of the room and it will identify it as a hot spot, but it won't actually spray straight away. It will monitor it and it will say, okay, as it continues to scan the room, it's still seeing the hot spot, but the hot spot isn't moving and the hot spot isn't getting any hotter. So it will continue to monitor it. If a log was to fall out of that fire and travel across a rug, then maybe the heat from the fire isn't significantly increasing, but that hot spot is traveling. So for that perspective, we would see that as a traveling fire, and it would determine that it needs to activate.
What are some of the biggest differences that you see in the technology? Or actually, I guess we could start more with fire protection and your conversations in the UK versus the US. So
you mean with regards to the smoke detector itself?
Just in general.
Just in general. Yeah. Okay.
I think a lot of times we get used to our US way, right? And I think probably a lot of people that would listen are used to our challenges and maybe some key differences.
I think in the last year, I've made several trips out to the States, and I've spoken to a lot of contractors, and you have the very similar issues than we have at home. And a lot of it is around codes. and regulations, and often just the interpretation of them codes and regulations. I guess one of the big differences that we do have in the UK is people tend not to, everyone adopts the same standards, same regulation throughout the country. Here you do seem to have a big variation, both between state and even county level. So we don't quite have that variance. There is a lot more excitement in the US about embracing new technology, and a lot more willingness to include it both in the codes, as well as the appetite seen from the contractors. In England, we're a lot more resistant to technology, and we like to stick to what we know, right? So all of our codes, similar to the codes you have here, there's normally an allowance there for, alternative means, right? An alternative system, which ultimately is what our system is. And like I mentioned earlier, our job really then is to be able to provide that evidence that the alternative system or the alternative way of doing something is as good as the prescribed way.
What are the main component differences that you've had from the UK or the European version to?
So the principle of the system is exactly the same as the UK version. What we did have to change through the UL requirements was we changed the pump. The pump was the biggest change in that we now have a brass pump. So that was a significant change for us to put a brand new pump in.
And I've been trying to convince you to go just the whole UK to go to 60 hertz the last 2 days too. But
yeah.
no.
So we've got a 50 hertz variant to satisfy the UK, the European market, and the Middle East is another market we're very keen to get into. So all the other parts of the equipment are exactly the same. The only variant there is just to handle the different electrical supplies.
What is it taking off as much, maybe in the Asian market, or?
So far, our focus has really been to get the system firstly approved with the UL. So we've got the UL certification now to UL 2167A. Now we have that. Our main focus is to ensure we have a smooth rollout in America. We're spending a lot of time educating and training contractors, as well as speaking to AHJs, designers, so that the AHJs are understanding when they get an Automis proposal submitted, they wouldn't have never seen anything like this before. What are they checking for in the working plan? What do they check for in their site inspections? So our core focus is really to spend the next 6-12 months developing that, getting that education message out. And in the meantime, yes, we're looking to then progress it off to particularly the Middle East, where there is a huge interest in this technology.
So as far as the adoption of this newer technology, is most of the hesitancy you're getting just due to it being relatively new and there not being a whole lot of information out there about it? Or are you running into some other roadblocks, either with contractors or AHJs, as far as trying to get this implemented, get the ball rolling?
Up until recently, we've hit huge roadblocks because what we were planning to do was have a pilot launch where we would be working with a certain amount of contractors, a certain amount of AHJs, and we were trying to get some home installations done. But what we very quickly found was until we had that UL stamp on the system, we couldn't even get pilot systems approved, which is understandable. We weren't allowed to share the test data that we had with UL until we'd got to that stage of the process. So that has kind of slowed up our pre-launch of the system, if you like, over here. But what we are seeing is a lot of contractors, particularly those who are working in areas where there's risk of freezing and seismic risk. That's where they see a big benefit to using this type of system, because it is a dry pipe system. So it takes away a lot of the risk or the potential risk there, where we use antifreeze and the problems that get associated with antifreeze. We can remove that potential risk.
Right.
What inspired Automist or Plumist to concentrate on residential?
So when we first started out and we were developing Automist, the main reason we do this differently to every other system is what we were really trying to achieve was to get a faster activating sprinkler system. That was always the main aim of developing a new type of system. And we saw, particularly both in the UK and the US, there were lots of both studies done on deaths of people where people had suffered deaths in buildings that were protected by sprinklers. And the common theme was because of the type of fire that was occurring, the sprinklers were just operating too late in order to save them people. And there were a lot of studies done, particularly in care homes in the UK, on that subject. So that was kind of put us back to the point of trying to find how can we create a fire suppression system that can activate earlier without having to wait for ceiling temperatures to build up to burst that bulb. And what we found is, particularly in the domestic setting, when you look at the fire loads, the fire risks we have in our houses nowadays, there's a lot more electrical risks, a lot more electrical fires, and these tend to be slower burning fires, right? They're not the fast, rapid developing fires that we get, from the cooking oil fires. So
comparatively,
yeah. So I think, the theory was always, if you can tackle the fire earlier, at an earlier stage, when there's less heat, less smoke, less gas in the room. We talk about suppression as a suppression system, but it's much easier to suppress or even extinguish that fire if you can tackle it at an earlier phase. And it just gives people better conditions to try and escape the property if you can operate that much earlier.
Are there any unique challenges for retrofitting?
So this is one of the benefits of an Automist system, is it's very easy to retrofit this system. We use a high pressure flexible hose to carry the water from the pump to the nozzle. As I mentioned earlier, it's dry pipe. So the installation of these hoses they're not that much bigger than a large electrical cable. So from an installation perspective, it's probably more in line with an electrical installation than it is a plumbing or a traditional sprinkler piping system. So from a retrofit perspective, it's very easy to install, it's very quick to install, and there's minimal disruption to the property in installing the system. So one of the big retrofit uses of the system back home is where people have been doing fire risk assessments, like person-centered fire risk assessments. And it may be that you don't necessarily want to put sprinklers in to the whole of a building. Perhaps you just want to put it in one part of the building, one apartment. So you can mitigate the risk. If you've got a resident who needs more time to escape than perhaps me or you would do from a property, that's a very common application for the system.
So it's full protection of the entire home then?
That's right, yeah. It's full protection.
All right. Can you share any stories where you've had this installed and what the owner or...
Yeah, I mean, we at home we used it for a much wider range of applications as to what it's going to be used for out here in the States. Just because of the way the codes work, there's a wider application use for it. But we've had some installations that spring to mind are a family who had some severely disabled children. And they wouldn't, again, like I mentioned, they wouldn't react the same way we would in fire. And it was very important to them that they were able to fit some kind of sprinkler or suppression system in the property to protect them from fire. but it had to be easy to be retrofitted. And the other applications where the retrofits are easier than a traditional mist or sprinkler system are often in buildings where there's asbestos present, because that tends to be around the ceilings. Very difficult working with sprinkler pipes around them ceilings and disturbing them. So again, being wall mounted helps with that, but so does also that use of the flexible hose.
What diameter is that?
Installed.
Hose?
So that's a 5/16.
A small diameter.
Home. So yeah, 5/16 hose, very small diameter.
So for a water mist system, how much water are we actually talking coming out? Because I know a lot of times, we recently had the local fire department in, and we were talking to them about their suppression activities, and they're coming in with the big 2.5-inch hose and just soaking the house, and you're probably out of that house for a year plus at that point, right? When you put in a sprinkler system, it's going to be less water, but we're still talking a fair bit of water. Is the water mist going to be a similar water usage, lower water usage? What does that kind of look like from how much water is actually going into the space?
Yeah, sure. So regardless of the application, generally the benefit of water mist over a traditional sprinkler is that it uses less water. So water mist uses 2.4 gallons of water a minute. Like I said, that's only through one nozzle that's going to activate. And the pressure requirement at the pump is just 15 psi. So it uses very low water pressure, very low water flow, and the system connects directly to the house water supply. So we don't need to find room for the tanks. So
or upsizing meters or any potential issues you run into.
Yeah.
Retrofit.
I mean, I think one of the biggest applications here is with ADUs. So often, if that you got your house, you've got sprinklers in your house, and you put in your ADU up, sometimes if the resident or the homeowner has to upgrade that water line into the house to feed the ADU, that can be a very expensive cost that you don't usually expect to pay either, right? It's a cost that hits late on. You've got the additional hassle of applying for permits quite often to get this work done. So really, Ultimist, the homeowner can often save them a lot of money where water supply is tricky. And again, up in the mountainous areas where there's the freezing risk, being in dry pipe, doing these ADUs is like a real good spot for Ultimist.
What does the electrical requirement look like? When we talk fire pumps, a lot of times we're talking higher voltage, 480 volts coming in. What's this look like? So you got a pump.
Yeah, electrical supply to the system is a 240 volt supply. It's the same kind of supply that you'd have to your oven or your washer dryer. So domestically wise, there's no special requirement. Houses these days will have the 240 volt supply there.
So how if I was a contractor and interested in getting involved in water mist, how do I do that?
Okay, so two options. You can visit our website, www.plumis.com, where we've got a section on there for contractors to register for more information. Alternatively, contractors can speak to their local Ferguson rep. So Ferguson Fire and Fabrication, they are going to be the exclusive distributors of the product. So they contact their local rep. They can explain more about the product and talk about pricing and training. So the training's being done directly via Plumis, but the product itself is being purchased from Ferguson.
I guess a question that I think of a lot is, I'm relatively new to it, and anybody that is listening, they might be new to it. You talked about the electrical element. Does the risk of electrical failure outweigh the pros of, say, having a dry pipe system with, sidewall sprayers? Do those benefits outweigh, the risk of, having an electrical shortage and, your system not functioning correctly?
Yeah. So the Ultimate system is, I guess the easiest comparison would be like your typical pump and tank system. Yeah. So the electrical risk there is the same. If the electric goes, the pump doesn't operate. Yeah. Nowadays, if the electric supply fails, if the house has got if it's a modern house with UPS backup or through solar panels and that kind of thing, you can take care of that. A lot of properties won't have that. And without electric supply, the pump's not going to operate. But there is no requirement at 13D to provide a backup electrical supply for the pump. So for this application that the system is designed for and is being used for, we're not overly concerned with providing backup battery. If you've got it, we can use it, great. If you haven't, then it is what it is.
Yeah, so generally speaking, with your 13Z system, it almost seems like the sprinklers need to be listed to a point. But with your alternative, obviously...
Yeah, I mean, maybe the other point to mention here is, with this whole certification process that we went through with UL, is they're not just listing the nozzle.
Right.
It's the whole system that is being certified by UL. So that includes our pump, our nozzles, the smoke detectors that are used with the system, the spray heads themselves, and the pump has to comply with the same pump requirements that any other pump does. Backflow prevention is the same requirement, have backflow prevention. Strainers are all tested the same way every other system is. But this UL certification is for the whole system.
So rather than the sprinkler system is more your, I guess, engineered type, where you're going to kind of figure out what needs sprinklers, place those sprinklers, figure out what the demand is, go back to your water supply. Yours is more similar to your special hazards type, where it's pre-engineered?
So yeah, it's a pre-engineered system. So as far as doing your hydraulic calculations go, there's really none required with the system. You do have a limitation on the design there, that we have a 200-foot hose length limit.
Okay.
So as long as you stick within that limitation of the 200 feet of hose, all your other calculations that you'd normally apply are already done for you with the system out of the box.
And that's a cumulative hose allowance, right?
Correct, yeah.
So if we've determined we go to Ferguson or to Plumas, and when we determine that we need more information, go to Ferguson, go through that channel, what does a training look like?
So the training is, we offer a design training for system designers, and then for the fitters we have a practical training assessment. So that's made up of two parts. So the first part of that is carried out online through our training portal, and then once that's completed, then you have a practical assessment. So this is where you can come to the FSA facility here in Texas to complete that practical assessment. We have another place in Colorado, and we hope to have some more over the next year or so throughout the country where that can be done. Alternatively, people can buy a training system and they can have a training assessment carried out at their shop.
We talked a little bit about basically you bringing the mist in, and it's obviously it's heat absorption properties. What do those droplets look like?
Okay, so
I know it's hard to not visualize that we're on a podcast. Well, what do they look like?
Yeah, get a video link here. So, I mean, the K factor on the nozzle, we're talking like 0.8 K factor.
Okay.
So very, very fine mist droplets. And as it comes out of the nozzle, the mist disperses. But what happens is, as the fire will suck in oxygen to feed itself, right? And it creates a natural turbulence to that fire. So what we're really trying to do is get these really fine mist droplets drawn into the turbulence that the fire is creating itself. And get, like I say, get as much of that water directly towards the fire as we can to cause the suppression.
So you said a K factor of 0.8, was that right?
Yeah.
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 We showed you some of the ones that are in our ceiling. That being said, a lot of times when we start to think of the 1.8 K factors, your lower K factors, there's always a concern of potential obstructions.
Yeah.
So what does this system do to try to combat that?
Our obstructions different from the conventional obstructions that you're normally considering. So generally speaking, you're considering vertical obstructions, things placed either side of the nozzles. We're more concerned with obstructions being placed.
You're good.
Really placing tall furniture next to the nozzles where it can significantly affect that spray pattern of the mist. So to combat that, we have quite strict design rules within our design software. So designers are given custom software that we supply to create these Ultimis designs. And we have what we call preferred positions. So the idea from the designer is they're going to put it in put the nozzle somewhere in the room where we don't expect you're going to get tall obstruction. So a typical example of that would be in the light switch position, right? People tend not to block their light switches with tall furniture. If the designer has put it in what we would consider a poor position, then we would reduce the spray pattern that we say that nozzle can provide, which would then force the designer to either move it to a better location within the room or add an additional nozzle in that room to compensate for that. So the way Ultimis works, the way you can see it on your training facility here when we activate it, the mist will actually disperse around objects. So of the 17 fire tests that UL put the system through, 4 of them fire tests included placing obstructions between the nozzle and the fire. So 2 of them were obstructions placed near the fire, and 2 of them were obstructions placed near the nozzle. So we had to pass both of them fire tests, as well as all the others. So that was a big consideration from UL, who worked with us to understand the design limitations of the system. And then they tried to put the obstructions in what they considered the worst possible place to see if the system could still perform.
So it sounds like once the mist gets into the room and is allowed to disperse, that natural entrainment of the air into the fire is kind of helping. So I guess the concern, most from an obstruction standpoint, is just allowing that mist pattern to kind of develop right out of the nozzle, and then
that's right,
and then let the fire do the rest of the work. That kind of the sounds of it. So
that's right. Yeah. So generally, the homeowner has they need to keep a 4-foot clearance on the wall where the nozzle is mounted, because once we've got that 4-foot clearance, the mist is dispersed enough to be projected into the room and have that effect there to suppress the fire.
It's a neat way of doing it.
Yeah. So the hose is 5/16, and the K factor orifice size is a 0.8 or whatever that diameter is.
Yeah.
How do you keep stuff from clogging the nozzle?
So that's a big consideration for us. Any water mist system, because your nozzle is the hole is so much smaller than a sprinkler. A sprinkler could probably push out a small bit of grit that might be in the pipe. So from when you're installing the system and you're doing the roughing, it's very important that the contractor protects the hose and seals the hose. And then you can flush water through the hose just to make sure that you haven't got any contaminations in your hose. The system itself has a strainer on the front of the pump to get any potential dirt maybe in the water supply coming in. And then there's also a very fine mesh filter just where the hose connects to the spray head. So before it hits the nozzle, there is like a secondary filter built into the system there at the nozzle.
And then the thoughts being that NFPA 25, their requirements for water mist should be followed.
Yeah.
And back to your manufacturer's instructions as well.
Yeah. So one of the big differences, I guess, between NFPA 750 and NFPA 13D is 13D will, it gives you, pretty much tells you like how the system should be installed and designed, right? It's pretty laid down, it's clear. With 750, a lot of the requirements refer you back to the manufacturer's DIOM. So things like the nozzle locations, obstructions that we just mentioned, where you consider them, because each water mist system is unique per manufacturer, whereas sprinklers are pretty interchangeable, right? As long as you're maintaining the same K factor, you can interchange most of the parts of sprinkler systems. That's not the case with water mist systems. So both from a design and installation perspective, the manufacturer's DIOM manual really lays out the rules of what you can do and what you can't do.
DIOM.
Yeah, design, installation, and operation manual. Maintenance
technical
manual.
data and DIOM.
So like it says, it covers the design element. All our design rules are there, including obstructions, the installation process, the operation, and as well as the aftercare and the maintenance side of the system. How to maintain the system is also included in that manual.
So before we wrap this up, is there anything you'd like our listeners to my accent came out bad there. My listeners to know, or anything you'd like to share?
I just think anyone interested in finding out more about this system and the applications it's suited for, there's applications it's not suitable for,
Right.
Not
put it in a storage warehouse, right?
No, absolutely. And this is just another offering that these customers can have. Word I'm looking. It's
almost a tool for the toolbox.
Another tool for the toolbox, yeah.
Right.
It can offer both the contractor advantages from an installation perspective, particularly on those retrofits. Offers the homeowner advantages when they come up, particularly like I mentioned earlier, with water requirements where that's an issue. So it's not going to be the perfect solution for everybody, but anybody that wants to find out more, either on our training or see the system, then by all means they should have a look on our website or email us directly.
We'll put the website in the description of this podcast as well. I know you've probably made a lot of happy significant others when actually probably husbands themselves as well, when we spend so much money, especially this time of the year. I guess it's December of 2024, and we're not going to worry about these sprinklers activating with all of these pine-scented candles in our house.
Yeah. I mean, I think that's where the insurance companies really like the system, right?
Yeah.
There's
and for our candle,
it's I think any consequential water damage that you have is certainly massively reduced. So let's hope we don't have it, but where we do, that's keep everyone happy.
Well, Steven, appreciate your time and looking forward to the trainings that we're going to offer here at AFSA and working further with you.
Yeah, thanks very much for having us in today.
Yeah, no problem.
This has been the K Factor Podcast. If you enjoyed the show, don't forget to like, subscribe, and share wherever you tune in to podcasts, or head over to our website for more. Reach out to us anytime at technical@firesprinkler.org. Stay safe and always learn as we keep the fire protection conversation going.